It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other,
where you put your knowledge to test
and battle it out with a test
to bring out the best in you. Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators,
with detailed videos
in every contest to improve your rating.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards.
Welcome to Unacademy. Welcome to Unacademy Semester Exams. Power Systems by C L Wadhwa MCQs backside bits we are looking at, and the objective questions today we'll be looking at from 101 to 150 questions today. And let me tell you about myself. I'm sravan Kumar, having 7+ years of teaching experience and mentored more than 5K students for GATE and engineering services, and also cracked GATE. Good morning, Augustus Balla. Welcome. And mentored more than 5K students for GATE and engineering services and also cracked GATE. Unacademy, let's crack it. Crack GATE and ESE with India's largest learning platform and get subscription to Unacademy. And you can also install Unacademy learning app from the Google Play Store and click on install. Then you'll get the daily live classes, structured courses, live tests and quizzes, unlimited access as well. And in Iconic subscription, you can have personal coach, study tracker, mains and questions, all the benefits. And in plus, you have daily live quizzes, structured courses, live test and unlimited access as well, as you have seen. And you can learn from the top educators of Unacademy, as you see. And we have GATE and engineering services batches year-long courses for all these subjects. And you have plus and Iconic subscription. You get all the benefits of plus and Iconic along with some special benefits as well. And you can also get subscription to plus for 24 months. My suggestion is to go for the 24 months. You can use my code YSK10 to get the maximum discount. And you can also go for the Iconic subscription for 24 months. For 24 months, you can use YSK10 to get the maximum discount on your subscription. We also have Evolve for GATE 2022 for electrical engineering. A new batch is starting 1st of February. And you can use my code YSK10 to get the maximum discount, and the top educators will be live for you, as you can see. And you have Evolve Ascent for GATE 2023. Those who are preparing for 2023 electrical engineering, a new batch is starting from 1st of February, and the top educators will be live for you. And you can use my code YSK10 to get the maximum discount on your Unacademy subscription. And you also have Evolve for GATE 2022 for electronics and communication system engineers. 1st of February, a new batch is about to start. Raju, welcome. Welcome to Unacademy. And you have Ascent for GATE 2023, EC, and you have 1st February, a new batch is about to start by the top educators of the Unacademy. And you can use my code YSK10 to get the maximum discount of 10% on your Unacademy subscription. So the topic for today is Unacademy Power System C L Wadhwa 101 to 150 questions. So let's look at the last question that we have discussed. The 100th question that we have discussed was corona loss increases with increase in supply frequency, conductor size, increase in supply frequency but reduction in the conductor size, decrease in supply frequency and conductor size. And also if you look at Third option, decrease in supply frequency and conductor size, and increase in supply frequency but increase in the conductor size. If you look at the corona loss, that is P, that is proportional to, inversely proportional to the size of the conductor and inversely proportional to the number of conductors per phase, and it's inversely proportional to the field uniformity, as you know. Now from this you can also say that, and also for corona you can write corona loss P is equal to, it is proportional to F plus 25. So it will increase with supply frequency and it is directly proportional to the frequency. It will increase with supply frequency but will reduce with conductor size, as you can see from this explanation. Now if you want to see the next question, 101 question, the corona loss on a particular system at 50 hertz is 1 kilowatt per phase per kilometer. The corona loss on the same system with supply frequency of 25 hertz will, you know, power loss is directly proportional to the frequency plus 25. You know this from the expression, so you can write P1 by P2 is equal to F1 plus 25 by F2 plus 25. Just try to substitute the values. You get P1 is already given 1 into 10 cube 1 kilowatt, by P2 is what you need to find, and it is 50. F1 is 50 plus 25 by, this is already given as 25 plus 25. So this will give you P2 is equal to, P2 will be given as 0.667 kilowatt per phase per kilometer. Now if you look at the options, this is C is the option. C is correct option. So this is how you will solve it. Next, coming to the next question, 102. A system is said to be effectively grounded. What is effectively grounded? It is solidly grounded without any resistance. If it is grounded, you say that if the system is grounded directly without any resistance, we say that the system is solidly or effectively grounded. So at when this is effectively grounded, the ratio of x0 to x1 will determine how effective it is grounded, and we can say that this x0 by x1 ratio, if it is less than 0 for solid grounded or effective grounding. So you need to have the ratio of x0 by x1 less than 3. The option is D. The ratio of x0 by x1 is less than 3. Now if you go for the next 103 question, for effective application of counterpoise, it should be buried into the ground to a depth of 1 meters, 2 meters, just to avoid theft, and none of this. See, for the effective application of counterpoise, let's look at the question once again. Let me take that question. Yes, here the question is, for effective application of counterpoise, it should be buried into the ground to a depth of, just it should be buried. There is no as such, there is nothing specified. So it is, there is nothing much, just to avoid the theft. We just there is no specification of either 1 meter or 2 meter or anything, but just to avoid the theft, we will do that. And if you look at the 104 question, if that R is the radius of the conductor and capital R is the radius of the sheath, just consider the radius. Let's take this as the conductor, the inner one. The radius of this is given as small r and the radius of sheath is given as capital R. The cable operates stably from the viewpoint of dielectric strength. So when does this cable operate? That is when R by R ratio is less than 1 by E, and you know the value of E as 2.719. So R by R less than 1 by 2.719 for the cable to operate stably. So R by R less than 0.368. So D, this is the answer. So for the cable to operate from the stability point, from stable from the point of view of dielectric strength, the R by R ratio must be less than 1 by E. Just remember this. Now 105th question, three insulating materials with same working stress. The same working stress and permittivity is 2.534 are used in a single core cable. The location of materials with respect to core of the cable. They are used in a single core. Let's assume that you have this. They are used on the same core. And if you look at the permittivities, let's say epsilon, epsilon and epsilon. So which must be near the core of the cable. As you know that the permittivities, the highest permittivity, 105th question. Yeah. The insulator with highest permittivity must be near the conductor. So that means you say this is E4, E3, E2.5. So E4 epsilon permittivity, epsilon 3 and epsilon 2.5. So this must be the order. So 4, 3 and 2.5 permittivity with highest permittivity. Insulating material with highest permittivity must be placed close to the core or the cable. Now, the three insulating materials with breakdown stress of 250 kilovolt per centimeter, 200 kilovolt per centimeter, and 150 kilovolt per centimeters, and permittivities 2.53 and 3.5. They have changed the permittivities with respect to the previous question. Now, if you look at this, now not only these permittivities are given, but the breakdown strength is also given. Now, when you have breakdown strength and the permittivities, you should consider the product of these two, that is 250 into 2.5 and 200 into 3 and 150 into 3.5 will give you 650, I guess. Yeah, this is 650, this is 600, and 150 times 3 is 450, and this would somewhere come around, just try to calculate this, 525. So the one with the highest product of these two, dielectrics breakdown strength and permittivity, with the product of these two, the highest value must be placed, the location of the material with respect to the core cable will be, that means first you need to place 2.53 3.5, because 2.53 3.5, option A is correct. So whatever the product is, whichever the product is higher, it must be placed first, and whichever the product is lower, it must be placed last. That is must be in the order of 600, 650, 600 and 525. It must be in the order of, it must be in descending order. So if you consider 650, it's 2.53 and 3.5. So option A is correct. Now let's look at the next question. 107. The coefficient of reflection of voltage short circuited line. So voltage reflection coefficient is given as ZL minus Z0 by ZL plus Z0, and this ZL is short circuited. What is short circuit indicates? This short circuit is ZL is equal to 0. So if you substitute 0 minus Z0 by 0 plus Z0, this is minus Z0 by Z minus 1. So the answer would be minus 1. If this is voltage reflection, if you want to have the current reflection, you have Z0 minus ZL by Z0 plus ZL. This is a characteristic impedance, but here we'll consider in transmission as the cable impedance. So if it was a current reflection, so we would have Z0 minus 0 by Z0 plus 0, it was 1. But here we are asked about the reflection of voltage, so the option is B. Option B is correct. Now, let's look at the 108 question. The insulation resistance of a cable of length 10 kilometers is 1 mega ohm. Its resistance for 50 kilometers length will be, its resistance for 50 kilometers length, insulation resistance. This is insulation resistance of a cable. The insulation resistance of a cable is inversely proportional to the length. It is inversely proportional to the length L. You can write, it is given for 10 kilometers it is 1 mega ohm, and for 50 kilometers how much will be the length? For 50 kilometers how much will be the length? So you can write it down as R1 by R2 is equal to L2 by L1. Let's take this as R1 L1 and R2 L2. So just substitute these values. R1 1 mega by R2 is the value that you need to find, and L2 is 50k by 10k. Just do this and you will get 0.2 mega ohms R2 value. So R2 will be 0.2 mega ohms. So the option is C. So the option is C. C and C is correct. Now the next question, if you just look at the next question, 109th question, the capacitance of 3-core cable between any two conductors with sheath earthed is 2 microfarad. The capacitance per phase will be, the capacitance, let's look at the question. Yeah, the capacitance of a 3-core cable between, it's a 3-core cable. So you have a 3-core cable and there is a capacitance between each. Any two conductors with sheath earthed is 2 microfarad. So the capacitance per phase will be given by, is equal to 2 times of capacitance of sheath. So it is 2 into 2, you will get 4 microfarad. So this is 4 microfarad. So the option is B. Option B is correct. Now let's look at the next. If delta is the loss angle of the cable, its power factor is. If delta is the loss angle of the cable, if delta is the loss angle, then its power factor will be. So if you consider, the voltage and the current and the resultant current, if you consider a circuit like this, and this is I, this is capacitor current and resistor. So this angle is alpha and this is delta. So what is the loss angle given by? It is cos of 90 . If you find the angle difference between these two, you'll get phi is equal to 90 minus delta. This alpha is equal to 90 minus delta. So alpha is 90 minus delta. So what is cos alpha is equal to cos 90 minus delta will give you sin delta. So you can say if the delta is the loss angle of the cable, then the power factor is cos alpha. That is cos 90 minus alpha will give you sin delta. So the answer is A for 110 question. Next, 111th question. The effect of bonding the cable is, the effect of bonding the cable is to increase the effective resistance but reduce the inductance. Now, whenever you bond the cables, that is, if you have cables like this and if you want to bond them, you can also bond like this the sheets, and you can also bond them like this, and the effect of this bonding is to increase the effective resistance and reduce the inductance, so that the leakage will reduce, or you can say that it is to increase the effective resistance and reduce the inductance. So the 11 answer is B. Next, if you are having 112, in order to eliminate the sheath losses, a successful method is, in order to eliminate sheath losses, what are the losses that you want to do? Eliminate sheath losses. In order to eliminate these sheath losses, what are the successful method? What is the successful method to eliminate this sheath losses? To transpose the cable along the cross bonding. To transpose the cable only, cross bonding the cable is enough. None of the above is effective. None of the above is effective. If you just to eliminate these sheath losses, to transpose the cable along with cross bonding, you will also transpose them as I told you just before, and with cross bonding also will transpose the cable with cross bonding, so that the sheath losses are eliminated. So the successful method can be, it is not only transposing or cross bonding, it is the both, to transpose and to transpose the cable with cross bonding, to transpose the cable with cross bonding. Right now, the sending end voltage of a feeder with reactance is 0.2 per unit is 1.2. If the reactive power supplied at the receiving end of the feeder is 0.3 per unit, the approximate drop of volts in the feeder, approximate drop of the volts in the feeder, that is Q is equal to EV by X cos delta. EV by X cos delta. So you can substitute that. Substitute the values that are given. So it is 0.3 is equal to V into delta V by X. So delta V is given as Q into X by V. So this is 0.2 into 0.3 by V is 1.2. That will give you 0.05 per unit. So this Q is equal to EV by X, or you can also write Q is equal to V into delta V by X. So this is a change that you get. So delta V is equal to Q into X by V. Q into X by V. What is Q given? It is 0.2, and X value you can see reactive power. Reactive power is 0.3. The reactive power is 0.3 and the reactance is 0.2. So Q is equal to V delta V by X. So delta V is equal to Q into X by V. Q is 0.3 and X is 0.2 by V is 1.2 voltage, sending end voltage. So delta V will be 0.05 per unit. Delta V will be 0.05. So it is C, answer C for 113 question. Now let's look at the 114th question. Now, next question, if the synchronous machine is overexcited, it takes lagging wires from the system when it is operated as. It takes lagging wires from the system when it is operated as. A synchronous machine, it actually gives, it does not take the lagging wires. So, none of the option is correct in this case. So, it is none of the above. 114, it is none of the above. Now, if the synchronous machine is This is over excited. This here it is under excited. It takes lagging wires from the system when it is operated as. Now, the synchronous machine is under excited. This is under excited and it is taking lagging wires from the system. It is taking the lagging wires from the system. When it is acting like a motor, it takes lagging wires, and when it's acting like a generator, it takes lagging wires from supply. Here it takes lagging wires from the infinite bus. It takes, so it will act as synchronous motor as well as generator. So when a synchronous machine is under excited, it takes lagging wires when it is operated as both synchronous motor as well as the synchronous generator. Now 116 question, a synchronous machine has higher capacity for, it will have higher capacity for leading power factors only. It will have higher capacity, synchronous machines will have higher capacity for, not for the lagging, or it does not depend upon the power factor of the machine, and it depend on the power factor of the machine. The answer is it has the higher capacity for the leading power factor. Now let's look at the 117th question. A machine designed to operate at full load is physically heavier and is costlier if the operating frequency is. So the machine is designed to operate at full load is physically heavier. It will be physically heavier and is costlier if the operating now if the operating power factor is lagging, you need to take the utmost care in order to eliminate the losses. So a machine designed to operate at full load is physically heavier and costlier if the operating power factor is a lagging power factor. If the operating power factor is a lagging power factor, you will need a lot of maintenance for the system, and to eliminate the losses, a much more precautions has to be taken. So a machine designed to operate at full load is physically heavier and is costlier if the operating frequency is lagging. Now, a synchronous phase modifiers are compared to synchronous motor used for mechanical loads have. Generally, these phase modifiers are designed for small shaft and higher speeds. What was the 118th question? The 118th question is skipped here. Let's look at that. 118th question. 118. The question is 118 question. Just let me write it down. For the same voltage, boost, the reactive power capacity is more for, the options are a shunt capacitor, option B series capacitor, and option C, it is same for both. So generally for the same voltage boost, reactive power of the shunt reactive power capacity of the shunt capacitor is as many times of 6 times of the reactive power capacity of the series capacitor. So you can say that for the same voltage boost, the reactive power capacity is more for Shunt capacitor. Shunt capacitor, the reactive power is more. Now let's look at 119 question. A synchronous phase modifier as compared to synchronous motor. A synchronous phase modifier. A synchronous phase modifier. 119 question. Yeah. If a synchronous phase modifier as compared to synchronous motor used for mechanical loads has smaller shaft. Generally, these phase modifiers are designed for the smaller shaft and higher speeds. So the option is B. Next, 118 question. For the same voltage boost, yeah, this is here. Yeah, we have done this question. For the same voltage boost, the reactive power capacity is, the slides have been shifted. Yeah, don't worry about it. For the same voltage boost, the reactive power capacity is more for the same voltage boost, the reactive power capacity is more for 118 question. Shunt capacitor. No. If IA1 is the positive sequence current, positive sequence, you know this. It has EA, Z and IA1. Right, this is the circuit for positive sequence current of an alternator, and Z1, Z2, Z0 are the sequence impedance of the alternator. The drop produced by the current will be, it is the product of these two simply, that is, it is drop IA into Z1. So the answer is A. 120, the answer is A. That is IA1 into Z1. That is the drop here. Z1. So the answer is 1. A. Now let's look at 121 question. For a system shown in the diagram below, this is a diagram. A line to ground fault, this is the fault on the line of the transformer, is equivalent to. See, whenever you have a fault, this is a transformer which is a delta star transformer. For a delta star transformer, if you just observe this, you have primary and secondary, and you have primary and secondary as well as primary and secondary. So if you have a fault, let's read the question. For the system shown in the diagram, a line to ground fault on the line side of the transformer is equivalent to a line to ground fault on the generator side, a line to line fault on the generator side, a double line to ground fault on the generator side, a three-phase fault on the generator side. Now if you look at this is a delta star transformer, and for a delta star transformer, if at all there is a line to ground fault, there is a line to ground fault, what will happen is it will reduce the flux in the primary, because they are on the same limb. On a single limb, three different limbs, you will have three windings. As a result of this flux, the voltage will be reduced, the opposition voltage that is present will be reduced, or you can say that it will, one of the line in the delta will get short circuited. We'll have this. So what will happen? This will result in a line to line fault on the generator side of the transformer. So 121 question, the answer is B. It will be a line to line fault on the generator side of the, it will be a line to line fault on the generator side of the transformer. Now let's look at the 122nd question. If you look at the 122nd question, the positive sequence, the question is all about the positive sequence component of voltage at any point of the fault is 0 when it is the positive sequence. The positive sequence component of a voltage at any point the positive sequence component of a voltage at point of fault is 0 when it is generally a three-phase fault. For a three-phase fault, 122, for a three-phase fault, obviously the positive sequence component of the voltage at the point of fault is 0. So for a three-phase fault, the positive sequence component of the voltage at the point of fault is 0 if it is a three-phase fault. It is not 0 in LL or LG or LLG. So the answer is three-phase faults. Now let's look at the next one. Pick out the correct statement. The negative sequence voltages, the negative and zero sequence voltages are maximum at the fault point and decreases towards the neutral. Negative and zero sequence voltages are minimum at the fault point and increases towards the neutral. The negative and zero sequence is maximum and zero sequence at the fault point and decreases and increases respectively towards the neutral, and none of this. So this is speaking about the negative and zero sequence components. So these will in general they will not occur, only they will occur when there is a fault. Only whenever there is a fault, then these will occur. That means whenever there is a fault, these are maximum at the fault. So negative and zero sequence are maximum at fault point and decreases towards the neutral and decreases towards the neutral. So as you can see, so the negative and zero sequence voltages are maximum at fault point and will decrease towards the neutral. They will decrease towards the neutral. So the option is A, 123 A. Next question. Let us look at the next question. For a complete protection of a three-phase line, a three-phase 3 earth fault relays are required, three-phase 2 earth fault relays are required, two-phase 2 earth fault relays are required, two-phase 1 earth fault relays are required. So anything can be used for the complete protection of the three-phase, but which is the more appropriate one, or which can be easily adopted, or which gives us the best protection can be chosen. So for a complete protection of three-phase line, a three-phase 3 earth or three-phase 2 earth, two-phase 2 earth fault relays, it's about the relays, and two-phase 1 earth fault relay if you are looking at. So you can use a two-phase and 1 earth fault relays for the 124th question. So for the 124th question, the answer is D. For the complete protection of three-phase line, for the complete protection of a three-phase line, you can go for two-phase 1 earth relays, two-phase relays and 1 earth relay. So these are the relays that can be used for the protection of a three-phase line. Now let's look at the 125th question. The phase comparators in case of static relays and electromagnetic relays normally are. The phase comparators in static relay, you have a static relay and an electromechanical relay. You have a static relay and an electromechanical relay. And what is that is asked is phase comparators. Phase comparators. So the phase comparators that can be used are, it can be a sine or a cosine comparators. For static and electromagnetic, you can use static sine or cosine comparators for static and electromagnetic relay. So for static relays, we will use cosine comparators. So we use cosine comparators for static relays and sine comparators for electromagnetic relays. So phase comparators in case of static and electromagnetic. For static, we use cosine and sine. So the option is B. So the option is B. Next, the order of lightning discharge current is, it cannot be 1 microampere, very less. It cannot be 1 ampere, which is very less. It cannot be 100 ampere, that's also very less. So it's 10,000 amperes or much more than that. So the discharge current of lightning is very high. Whichever is the very high value that you find in the question paper on the competitive exam, then you can choose that option. It is very high, of the order of 10,000 amperes in this particular given question. So the answer of 126th question is 10,000 amperes. 10,000 amperes. Now let's look at the next question. 127th question. Now the magnetizing inrush current in the transformer is rich in. It is not the magnetizing current, it is magnetizing inrush current. So generally magnetizing current is rich in, if you take the magnetizing current, you can study that in the transformers, magnetizing current is rich in third harmonic. It is rich in third harmonic, but magnetizing inrush current is rich in second harmonics. So this is the difference between the magnetizing current and magnetizing inrush current in a transformer. So you can say that the inrush current, magnetizing inrush current in transformer is rich in, if it is magnetizing current, it is third harmonic. Because it is the magnetizing inrush current, it is second harmonic. So the option is D. So the answer is D. 127 D. Now let's look at the next question. The effective use of counterpoise wire. What is the effective use of counterpoise wire? So it is for a So effective use of counterpoise wire, its leakage resistance should be greater than the surge impedance. Its leakage resistance should be less than the surge impedance. Its leakage resistance should be equal to the surge impedance, or the two resistance may have any relation. See, the counterpoise is generally used in under the towers, like the rods that you have. So it should give a path, protection path for the passage of the fault current. So the resistance of should be, it should be very less. So we can say the resistance is, leakage resistance is less than the surge impedance. So it should be less than the surge impedance. So the 128th question, it is RL is less than ZS. So the answer is B. Its leakage resistance should be less than the surge impedance. Now if this is greater than the surge impedance, there will be a flashover and a large spark will occur. Now let's get to the 129th question. This is an inertia constant of two group of machines which do not swing. This is do not swing. Don't swing. If they swing, you already know that we have seen that P1 is m1 del d square delta by dt square, and P2 is m2 d square delta by dt square, and delta is same in both the cases. So you get P is equal to m1 plus m2 into d square delta by dt square. That is, when they swing together, this is the case. When they do not swing together, you can just get it as m1 m2 by m1 plus m2. When they do not swing together, we'll get it as m1 m2 by m1 plus m2. So the answer is C. Option C, M1 M2 for the 129th question. M1 M2 by M1 plus M2. Now let's look at the next question, 130th question. If the inductance capacitance of a system are 1 Henry and 0.01 microfarad, 1 Henry and 0.01 microfarad respectively, and the instantaneous value of the current interrupted is 10 amperes. Instantaneous value of the current interrupted is 10 amperes. The value of shunt resistance across the breaker for critical damping. Critical damping is 1. This is called as the critical damping case. That means you'll get this case when the condition for this critical damping is R is equal to 1 by 2 root L by C, the shunt resistor. So to calculate that, you need to write 1 by 2 root L value is 1 Henry and 0.01 micro, and if you calculate the R value, it will be 5 kilo ohms. So the answer for this question is C, 5 kilo ohms. Just take R is equal to 1 by 2 root L by C for the critical damping. Now the load flow solution, the quantity specified at a load bus R. We have already seen this question. So this we already know that it is a load flow solution, quantity specified at load bus. So the load bus, you already know that the quantity specified are P and Q. For a load bus, the quantities specified are real and reactive powers. You need to just remember that table that I have shown you in the last class. The solution of next question, 132nd question, 131 question is skipped. Yeah, this is the one. Yeah, 132nd. The solution of coordination equation. This coordination equation takes into account the solution of this coordination equation actually uh, takes into account both power loss and power demand. So if you find the options, if you just look at the options, all the system constraints, all the operation constraints, all the system and operational constraints, none of this. So as it takes into account, the solution of coordination equation takes into account the power loss and the power demand, the option is none of this, which is not specified. So 132 is D. Option is D. Let's look at the next question. For a two bus system, if the change in the load at bus is 2 to 5 megawatts, load is changed from 2 to 5 megawatts, and the corresponding change in generation at bus 1 is 8 megawatts, the penalty factor, what is the penalty factor for bus 1? Penalty factor for bus 1 is equal to penalty factor is 1 by lambda is, you can just take lambda value is equal to 1 by 1 minus dou p by dou pl by dou p1. So that is 1 by 1 minus is 1 by 7 that you get, it is 0.42, which is not available in the question. So the answer is none of this. 133rd question, the answer is D. So 0.42, the option is D. Next 134 question, if the penalty factor of a bus is 2 in a two factor bus system is 1.25, if the incremental cost of the production of bus 1 is rupees 200, 134 question, yeah, 200, it is given as 200. So the value of incremental cost IC is 200 and penalty factor is already given as, so it is already given as 1.25. Penalty factor is given as 1.25. So the cost per received power at the bus 2, so this is given by lambda is equal to L into incremental cost. This is 1.25 into 200. If you just take this, you'll get 250. So the option is 250 megawatt hour. What is L is equal to? L is 1 by 1 minus increment 1 by 1 minus incremental cost, that is you'll get L value and you can substitute it here 1.25. So then you'll get the value as 250. Now let's look at the next question, 135th question. The cost of generation is theoretically minimum. It is theoretically minimum. 135th question. The cost is theoretically minimum when the constraints are not considered. Theoretically it will be, you need not consider them, the operational constraints or the system constraints. So the cost of generation is theoretically minimum if the constraints are not considered. Now the incremental transmission loss of a plant is, it actually can, it is generally taken as between 0 and 1. You generally study as 0 and 1, but it can also have negative values. So 0 less than ITL less than 1, but it can also have some negative values also. So this is option is can be positive or negative. 136 C, I guess. Yeah, it is C. It can have both positive and negative. Now let's look at the next question. If PM is the maximum power transferred, the loss on the system is. So obviously maximum power transfer theorem, let's consider as we know, if PM is the maximum power transferred, then the loss is PM by 2 because only 50% of transfer takes place and the rest will be loss. So the loss is PM by 2. Maximum power transferred is PM. So let's say you have X power that is transmitted. Then as you know the maximum power transfer it is X by 2. So the option is PM by 2. Now let's take 138th question. If X is the system reactance, R is the system resistance, power transferred is maximum when? 138th question. Yeah. Now if power transmitted is, options are given wrong here I guess. 138th question. Let's look at them. 138, yeah. This is not root 2, this is root 3R. X is equal to, let's erase this. That's what I was thinking. X is equal to root 3R. So option C. No. So the power transferred is maximum whenever you take the power maximum, when if X is the reactance and R is the resistance, then the power transferred is generally maximum when the reactance is root 3 times of the resistance. So this is the answer C. 138th question, answer is C. So for the maximum power transfer to take place, reactance is root 3 times the resistance. Now 139th question, inertia H of a machine is 200 MVA is 2 per unit and its corresponding 400 MVA will be. So its corresponding 400 MVA, you already know that M is equal to SH by pi F, or you can also write S1 H1 is equal to S2 H2. S1 H1 is equal to S2 H2. Now substitute the values. 2 into 200 is equal to 400 into or H2. You can just take it as. So you'll get H2 is equal to, what is the value of H2 that you get? It is 1 per unit. So the answer is C. So 139th question, answer is C. Now let's look at the inertia constant of two group of machines which do not swing together M1 M2 such that M1 is greater than M2. The inertia, so M1 inertia is greater than M2 inertia. It is proposed to add some inertia to one of the two groups of the machine for improving the transient stability of the system. So that is, in order to improve the transient stability, we are adding some inertia to the one of the two groups. It should be added to M1 or M2, or it does not matter whether to add M1 or M2. No, it matters because the inertia of M1 is higher than M2, so we will add it to M2. So that will make a balance. That is, so it is M2. The inertia constant of two group of machines which do not swing together at M1 M2 such that M1 is greater than M2. So we should obviously take M2 and add inertia. Next, so the answer here is B. Now let's look at the 141 question. Tick out the correct one. SCR short circuit ratio. Short circuit ratio. Let's consider that. Higher the short circuit ratio, machine, the heavier is its rotor. Higher the short circuit ratio. Short circuit ratio is actually directly proportional to the size of the machine. It is directly proportional to the size of the machine. So higher the size of the machine, the higher is its rotor, heavier is its rotor. It's also directly proportional to the air gap. It's inversely proportional to the impedance. You need to remember this, but that is needed in this case is 141. Higher the SCR of the machine, heavier is its rotor. That's the answer. Answer A. Now let's look at the next question. 142. A 100 by 10 volts 50 volt ampere transformer is converted to an auto transformer. So you are converting a transformer with a 100 by 10 50 MVA 50 volt ampere, sorry, 50 volts to an auto transformer. You have an auto transformer. The rating of the transformer is, so you need to find this voltage and this current. This voltage is already given, so this voltage will be 110 volts. You need to find this current. What is that current here? This current is same as that current, so let's try to determine that. So 50 by 100 is equal to 0.5 and 50 by 10, this is 50 by 100, the current in primary, 50 by 10, so volt ampere by volt will give you 5 amperes. So you would get the rating of the transformer as, transformer rating is equal to 5 into 110, that is 550 volt amperes. So the answer is A. So ultimately you can say the answer for this question 142 is A. Now let's look at the 143rd question. A 100 kVA transformer has maximum efficiency of 98%. When operating at full load, its full load copper losses are. So it is 98%. If you just take it down, it's 98%. So it will be 4 times. So copper losses are 4 times of the iron losses. You can write the equation of efficiency. It is V2I2 cos phi 2 by V2I2 cos phi 2 plus iron losses plus copper losses. So from this you can write a percentage of the load, half load. So you just take down is X. So from this you can get that it is, you just try to calculate this, you'll get 0.98. 98% is equal to 50 by 50 plus 2 omega I, and you'll get omega I as 0.51. So you'll get the answer as iron losses as 0.51 and copper losses as 2.04. 143rd question, option A. So this is the right answer. Next 144th question, a voltmeter gives 120 oscillations per minute. So per second it is 120 by 60 per second. When connected to a rotor, the stator frequency is 50. So Fs is 50 Hertz. Then the slip is equal to Fr by Fs, right? Rotor frequency by stator frequency, or so you can say that into 100. So it is 2 by, this is 2 times, right? 2 by 50, that is 4%. The answer is B, 4%. So 144th question, the answer is B, 4%. Next question, if the excitation of a synchronous generator fails, excitation is failed, it acts like a synchronous motor, synchronous generator, induction motor and induction generator. So whenever a synchronous generator fails, it will still start working. If the excitation fails of a synchronous generator, it will act as a induction generator. So answer is D. Whenever excitation fails, it will act as an induction generator. Whenever prime mover fails, it will act like a synchronous motor. So just remember that. So excitation of a synchronous generator fails, then it will act as an induction generator. Next, 146. I and T are the line current and torque respectively when DOL started is used. For DOL, you get I and T. These quantities when star delta starter, for a star delta starter, I will be root 3 times and T will also be root 3 times. You just need to consider the starting and full load torques and apply it, because the current in the star delta starter will be I is equal to I by root 3. So that's how you get T starting by T full load is equal to I starting by I full load by whole square by. So if you just try to substitute this, you will also get 1 by 3 times of 146th question, right? So you will get 1 by 3 times. So torque will be 1 by 3. Yes, this is 1 by 3 times. So the options are, it is I by root 3, T by 3. This is T by 3, I guess. So let's look at the question. Just have a doubt in that question. 146. Yeah, it's T by 3. So the second option is this T by 3. So the answer is I by root 3 and T by 3. So current will be root 3 times, and for the torque you will get 1 by 3 times if you substitute I by root 3 whole square. So it is current will be 1 by root 3 times and torque will be 1 by 3 times. So the answer for 46th question is B, 146th question. Next, consider the 147th question. A 100 kVA transformer has 4% impedance and 50 kVA transformer has 3% impedance. So 100 kVA 4% impedance and 50 kVA has 3% impedance. 147th question. Yes. Yeah. When they are operated in parallel, so they are operated in parallel. Which transformer will reach full load first? Full load. Obviously, the transformer with less percentage of impedance will reach. So the answer is 3%. So the transformer with less impedance percentage will reach the full load first. It's not based on the kVA, it's based on the percentage of impedance. 148. In EHV transmission lines, efficiency of transmission can be increased. You need to increase the efficiency of the transmission line by decreasing the corona loss. This can be achieved by, obviously you know that, using bundled conductors. Corona loss can be reduced by the use of bundled conductors. So the option here answer is B. Next, 149. An alternator having induced EMF of 1.6 per unit is connected to an infinite bus of 1 per unit. The bus bar reactance is 0.6 per unit and the alternator reactance is 0.2 per unit. The maximum power that can be transferred, 149th question. 149th question, right? Yeah, the maximum power that can be transferred is P is equal to EV by delta, EV by X. So delta is 1.6 by 0.8. So that will give you 2 per unit. So the answer is 2 per unit. Option B. The last question of this session today. If one phase of a supply goes off, one phase is gone. In case of a three-phase induction motor, for a three-phase induction motor, if one of the supply goes off, it is called as single phase. We'll call this as single phasing. And the motor comes to stop, draw double the initial current and continues to run, draws 1 by 3 times the initial current and continues to run. So as you know that if one is supply is off in a three-phase induction motor, so that will be 1 by root 3 times. So the motor draws a 1 by root 3 times initial current and continues to run. So let's look at the options. So these were the solutions for the power systems by C L Wadhwa 51 to 100. Let's look at all the questions once again in the next few minutes, and let's close this session. We'll continue the same session. Now let's look at these questions. Yeah. So if you just try to, corona loss of a particular system is 50 hertz, 1 kilowatt per kilometer. Corona loss for the same system, if the frequency is changed, you need to use this expression, and when you find, you'll get 0.667. Now a system is said to be effectively grounded or solid ground. For solid grounding, x0 by x1 ratio is less than 3. Now, for effective application of counterpoise, there is no particular depth that is required, but it is just to avoid theft, you can say. Now, if the radius of the conductor and radius of sheet are given, the ratio of these two must be less than 1 by E, and that is less than 0.368. And three insulating materials with the different permittivities, if they are given, you should consider the highest permittivity material close to the conductor. And instead of giving the permittivities, along with that, if the breakdown strengths are also given, you need to product the breakdown strength with the permittivities, and whichever has the highest product, that should be near the cable. Now you know reflection coefficient is ZL minus Z0 by ZL plus Z0. Now for short circuit impedance, load impedance is considered to be 0. Then if you substitute, you'll get -1. Now insulation resistance of a cable of 10 kilometers is 1 mega ohm. So insulation resistance is inversely proportional to the length. Just try to apply this. R1 L1 is equal to R2 L2. You'll get the value of R as 0.2 mega ohm. Now the capacitance of three core cable between any two conductors with sheath earthed will be 2 times of sheath, that is 4 microfarad. Now if delta is the loss angle of the cable, then the power factor is, you will get it as sine delta. So for the effect of bonding the cable, it will increase the resistance and reduce the inductance. In order to eliminate sheath losses, you will transpose along with cross bonding. And the sending end voltage of a feeder reactance is given, reactive force applied at the receiving end is given, the approximate drop in the feeder is calculated by using an expression, you will get 0.05. Now when synchronous machine is overexcited, it taking lagging wears, so it does not happen, so it is none of this. So a synchronous machine with underexcited taking lagging wears, it will work both as synchronous motor as a generator. A synchronous machine has highest capacity for leading power factors, and a machine designed to operate at full load is physically heavier if it is operating with lagging power factor. Now for the same voltage, you can see this question here, the same voltage boost, the reactive power capacity is more for the shunt capacitor, and asynchronous phase modifiers are generally designed with smaller shaft and for higher speeds. Then if you consider the positive sequence current, then the drop will be IA1 into Z1. Now in the system given, if you look at the fault here, there will also be an effect in the primary side of the transformer, which will be if this is a line to ground fault, this primary side will be a line to line fault. And the positive sequence component at any point will be 0 if it is a 3-phase fault. Now, if you are asked to take out the correct one, as you know, negative and 0 sequences are maximum at the fault and decrease towards the neutral. So for the complete protection of a 3-phase line, you can use the minimum relays required, that is 2 phase and 1 earth are sufficient. Now the phase comparators in case of static and electromagnetic relay, you know static relays use cosine comparators and electromagnetic relays use sine comparators. The order of lightning discharge current must be taken as high as given in the question. So magnetizing current will have third harmonics and magnetizing inrush currents will have second harmonics. For the effective use of counterpoise, the leakage resistance must be less than the surge impedance. You can see that. The inertia of machines which do not swing will be M1 M2 by M1 plus M2. If the inductance and capacitance are given, for the critical damping, R is 1 by 2 root L by C. You will get the answer as 5 kilo ohms. In the load flow solutions, the quantities at load bus are P and Q. The solution of coordination equations will consider the power loss and power demand, but it's not given in the question, so we have taken none of the above. So for a 2-bus system, there is the generation change in the load bus and everything is given, and we are asked to find the penalty factor. You will get 0.42, which is not given in the answer. Now, if the penalty factor is given and incremental cost is also given, cost received power at bus 2, cost of the received power will be 250 megawatt hour. The cost of generation, theoretically, you need not consider any constraints. The incremental transmission loss ITL of plant can be positive or negative. When maximum power is transferred, the loss will be half of it. If X is the system reactance and R is the resistance, then for maximum power X is equal to root 3 times of R. And when the inertia is given of a machine is given and the corresponding value of 400 MVA will be, you can calculate by using S1 H1 is equal to S2 H2. And the inertia constant of two machines which do not swing together is given. So you need to add inertia to the machine with lowest inertia. So for a SCR of a machine, if the higher the SCR, the machine rotor will be heavier. You need to convert a transformer into auto transformer. So when you find the auto transformer rating, you'll get 550 volt amperes in this. So you are given the maximum efficiency of 98% at full half load. So power losses, full load losses will be iron losses 0.51 and copper losses 2.04. A voltmeter is giving 120 oscillations, that is 2 oscillations per second when connected to rotor, and stator frequency is given, supply frequency will be 4%. And if the excitation of a synchronous generator fails, it will act as an induction generator. And I and T are the line and current and torques in DOL starter. Then in star delta, it will be I by root 3 and T by 3. 1 by root 3 times current and 1 by 3 times the torque. And 100 MVA transformer has 4% impedance and 50 MVA transformer has 3% impedance. So to reach full load, the transformer with less impedance will reach the full load first. The efficiency can be increased by decreasing corona loss using bundled conductors. Next, an alternator having induced EMF and it is connected to infinite bus bar with reactance. So the maximum power that can be transferred calculated as 2 per unit. And if the one phase of a supply goes off, it will draw 1 by root 3 times the initial current and continues to run. So these are the questions from 51 to, it's not 51 to 100, it is from 100 to 101 to 150 questions. That's what we have seen. 101 to 150 questions. This is must be the old slide. So these are the power systems by C L Wadhwa MCQs 101 to 150 solutions. So as I always tell you, we have India's #1 study channels on Unacademy. And do like this video, subscribe, use my code YSK10 to get the maximum discount on your Unacademy subscription. Click on the bell icon to get notification of my classes. You can also join our Telegram group, and please do like and share this video. And thank you all for joining me today on this session on power systems MCQs, and thank you all.